Hello everyone, welcome to Lytheric Papers. It's been a while since I last recorded a video. In that video I had promised to produce a video that calculates the spin or the magnetic moment of particles. So to start off with, I would like to basically calculate the magnetic moment of a proton. Before we go on, just as a reminder for those that are new here, the second electromagnetic wave is based on the fact that these particles are made of, like an electron, out of, for instance, the electron 10 to the power of 20 attons. So basically it's layers and layers of atoms that make up this electron. And if the electron is jolted, the forces that are holding these atoms to the electron are not strong enough, and these atoms peel off in a corkscrew manner. And this helix or corkscrew is self-sustaining because these atoms have both mass and a charge, and these forces end up in an equilibrium, and this equilibrium forces the speed of light. So as you can see here, this is a rendering of such a second electromagnetic wave, and this is why light, contrary to a radio wave, does not propagate 360 degrees away from an antenna, but propagates like a laser in a straight line away from the electron. For those that would like to go more into detail, below I have linked the 5 major videos that pertain to the second electromagnetic wave, starting with the general theory explained. So I think that'll get you started and will help you understand what I'm saying here in this video. So the magnetic moment is basically the current times the area that it circles around, and that basically then is the area. For instance, at the equator is the area underneath the cut through sphere. So it's the area under the equator of the sphere. And for the current, it's basically the charge time, the sum of all charges times the rotation speed. So if you think of it, that the electron or the proton is made out of rings and rings and rings from the equator up to the pole of these attons. So if you add up all the rings, outer rings of a proton, then, or an electron, you then achieve basically the surface, the number of atoms on the surface of an electron or a proton. The reason why I'm using A0 is the number of atoms on the surface of an electron, which create the charge of an electron as shown in previous videos. So the assumption here is that, of course, the number of atoms that produce the opposite positive charge on the proton have to have the same number. So that leads to the equation Q0 times A0, A0 being the number of atoms on the surface of an electron, which would then produce, if they are positive atoms, the positive charge of a proton, times the rotational speed, times the area underneath the half of the sphere of a proton, times a factor. And this factor is important because remember that each of these rings has actually a different area underneath that sphere that it cuts. So to calculate that factor, I basically created a simple Excel sheet. I created a sphere out of 20 attons in diameter. I then created the area underneath each ring from the equator up to the pole, and then I basically calculated the average area underneath that cap of the sphere. So from the equator, which is the full half of the sphere, all the way up to the poles, and that factor then turns out to be 0.66. So having done that, using the previous values of Q0, A0, and AN, and F, the factor A, and additionally, assuming that Vs is C, I achieve the exact measured value for the magnetic moment of the proton being 1.41, 10 to the power of minus 26. The reason why I chose C is that there has to be a reason for this spinning. And the reason that the hypothesis that I used here was that basically the second electromagnetic wave buzzing past a proton, similar to a string pulled by on a top, leads to the top spinning. So does the charged particles of the second electromagnetic wave pulling the proton along with it. So all these assumptions actually are very logical, very straightforward, and they produce the exact correct measurement amount. And yet I am not convinced that this is the complete answer, but I will later show why this math, even though I don't believe that it's in terms of physics being correct, actually does produce a correct value. But having said that, similar to what Tesla says, it's not math that dictates the world, it's physics. So math is a description. And the fundamental issue here is that the proton has to be a lot larger than the electron if the structure of the proton is similar to the electron, which it kind of has to be. Otherwise, you'd have several different attons, and then the light would have very different properties. So having said that, basically the proton has about 110 times the surface of the electron, and then there would be the problem that the attons, the positive attons, would have to be evenly distributed and have a lot lower, and that's a lot lower charge density than the electron. And there is no really good physical explanation for such a different distribution of these surface attons on the proton compared to the surface attons of the electron. So this leads to the question of how and why are particles different in size and stable, and some particles are not stable. And again, the stability depends on the forces, the equilibrium of forces. So having said that, again, the atom has a mass and a charge. So you have two forces that will create an equilibrium. And this equilibrium depends a little bit on the structure of both the electron and the proton, which are really the only two real stable particles. The neutron can be considered semi-stable, and it basically decays into a proton. But for instance, the muon is quite unstable and typically decays in about, I think, 2 seconds or something like that. So the charge force of the Atton depends on its position in the Atton lattice, which kind of makes a simple calculation not quite so easy. So to progress on this nonetheless, I've created the picture of a fundamental basis formation that is made out of 8 attons. And I have distinguished between a charge that is embedded in this base lattice formation and the charge that is attached to this base lattice formation, which is basically the surface charge. So the charge 2 is the embedded QEB, and the charge 1 is the surface charge. And the calculation shows that the embedded charge is embedded with about 10 times the force of the surface charge. So the proton radius is about 10 times larger than the real electron radius. Whereas the electron radius has, on the 20 outer layers, always a QOX layer in between the QEB layers, or the base formation layers. So this already gives you an indication for the explanation why the proton can be larger than the electron, because the proton is formidably made out of the base formation, and the electron always has this QOX layer between the formations, the base formation of the 8 attons. So a little bit of a wrinkle in this is that, of course, when you get up to the poles, the charge force, contrary to the centrifugal force, is no longer perpendicular. But you could also argue that the charge can slide on the sphere of the atton below it. So the surface atton can slide in direction of the perpendicular centrifugal force. So just for the purpose of this calculation, I use the assumption that it can slide, and thus align with the centrifugal force. So just for the clarity of definitions, I've drawn, the embedded charge force and the surface charge force, and also basically, as you can see here below, I have the spin, and I just rendered here with 2 layers, and basically the FMOXN is then the centrifugal force. So with that leads to an interest assumption or hypothesis that the actual positive charges accumulate at the poles of the proton. And basically the reason for this is the size and stability of the proton is derived from the fact that the centrifugal forces are dependent on the rho, or the ring of the protons, whereas the largest force is at the equator. So again, we're differentiating here between the force of the non-embedded charge and the embedded charge. And so the embedded charge basically can handle about 10 times the centrifugal force, which is largest at the equator. So that means that the external attons that can only handle the FQOX force are basically forced to exit the proton, and so they can only stick to the proton up at the poles. And that leads to this interesting construction of the proton. And there are several indications that this might be actually a pretty good explanation, because if you go back to chemistry, the electrons orbiting the proton tend to orbit in a plane. And this would also give a good explanation why the electrons orbit in preferred planes. So if you look at it, the size of the proton is limited by the embedded charge force, and the size of the electron is limited by the external charge force, FQOX. So this leads to, unfortunately, a little bit more of a complicated magnetic moment calculation, which I'm going to have to defer to another video and bring this video to a close. But as you will see, that this also leads to a correct calculation of the magnetic moment on the proton, and also a correct calculation of the magnetic moment of the electron. And with that having said, I might, though, before continuing on with the magnetic moment, produce a couple of videos about the interaction of light in a medium. For instance, why does actually light slow down in a medium? And the interesting part of that really is that it actually changes its velocity at the point of entry. So within the first couple of molecules, the speed of light changes. So, and at the same time, why does it maintain its frequency? And then also the questions arise, why do you have the different polarizations and reflections, internal reflections, and also evanescent light? So with that having said, I hope this video helped to understand or why the second electromagnetic wave does have some standing. And I hope to see you in the next videos, and hope to have a few more subscribers that are looking forward to seeing some more interesting connections here that are created by the hypothesis of the second electromagnetic wave. So with that having said, thank you very much, and take care. Thanks. Bye.